10-second latency, it looks like. Okay. It's kind of neat to be able to stream from the desktop here. Anyway, so the way we're going to do this, just going to real quick walk through what we're doing. Working with SDL now. So start in main, keeping this to an absolute bare minimum. We declare the Veraldo object. The constructor enters the main loop and falls through when you quit. And that's all main is. So then Veraldo is going to be doing a lot. Right now I'm setting up the environment, screens, all the SDL stuff. This part's going to change. Right now I've got it so it launches, there's like a splash screen sort of thing, but I'm going to need to change how that operates because it's like I'm changing it so it covers the whole screen. So I'm reading out the screen width and height based on the resolution of the screen. Probably be easier if I just show it off real quick. So there are two different windows. We've got this window. They're both borderless, so no decorations. They're just covering some portion of the screen. So this one runs OpenGL. It has an OpenGL context associated with it. This one is an SDL renderer, which I'm using to do fonts. My thinking is to have buttons in the SDL window, the SDL renderer window, which I'm calling the informational window. So I'm going to have buttons here to interact with the OpenGL operation, and then I'm thinking, some sort of logging in the command line. So it's not there yet, but made some strides in the past few days. So then when you hit escape, it pulls up the exit splash screen. It's kind of cool stuff that I found. Just go through this. With SDL, it supports some different stuff where you can get some information on your platform, like where the program was launched from, which I believe you can get anyways. But anyway, platform you're running on, because this supports Windows, Mac, Linux, Android, and iOS. Screen resolution, logical CPU core, system RAM, and battery state, which is interesting. You can pull stuff from the clipboard. You can put stuff into the clipboard. You can query whether there is stuff in the clipboard. So that's kind of interesting. Be able to do something like, copy-paste type interaction with text. So that'd be interesting to mess with. Let's just go through everything in order. So right now I've got it initializing SDL. We have the info dump that runs, and all that's doing is where do we launch from, what's the screen resolution, what platform are we running on, what screen resolution are we looking at, or just report that screen resolution, how many CPU cores, how much system RAM, and then this is how they're structuring the power info. So there's a state associated with whether you're on battery, no battery present, so like a desktop or something, charging or charged, and then there's the number of seconds remaining and the percentage charge. So some kind of cool stuff there. Maybe some maybe something you could use that for at some point. Next we're initializing the TTF font rendering, and I've got that working pretty well now, I think. So it's basically, I need to clean up this code quite a bit, but we initialize the TTF thing, open a font that I've got locally, and you set the font size there. So once you have that font loaded, you're able to render text easily. So after that, we're creating the OpenGL window, and so just all the flags we want for red, green, blue, alpha, size, the double buffering, multi-sample buffers, so that we can do more than one sample per pixel, 4.5 GL context, and we're just using the core context. So this is why I'm pulling the screen width and screen height, is to position the windows. So I have the X starts at a third of the way across the screen, and 0 in the Y. And you've got the width is 2/3 of the screen width, and the height is the entire height of the window. So you see that's 2/3 in the entire height, and this is all the OpenGL area. So that's not anything we need. The border, we set the border to false, and basically all that does is remove the decorations so that we don't have the close, minimize, full screen, those, and the title bar. This is a logging thing. It's very verbose. It's just kind of all the shit that OpenGL wants to tell you. I have ways to bring it down in terms of the number of total messages, because it's not super right. I've got these to where I could set it to, if I run it like that, then I'm not going to get any of these because they're all severity notifications. So right, keeping it a lot less verbose there. What that's reporting is it's actually interesting. So we're registering the debug callback before SDL then starts to interact with OpenGL, which is interesting. Oops. Let's get back to that. Okay. Screwed that up. Yeah, so like I say, it's not reporting all that stuff now. It's just the other information. So the next thing that we'll just finish up the GL stuff really quick. We set the clear color in clear, and then present that buffer right with the swap window, and then there's not really any reason to have a delay there. Next thing is creating the info window, and for all the components, we're not there yet. That's going to be a big project. I'm basically, I'll get into it once I finish explaining this part of it. The info window is just a window with an SDL renderer associated with it, right? And then again, setting the bordering to false. Load up a splash screen, which is now broken because I changed how the screen resolution was handled. I'm gonna have to change how that looks at some point. So it pauses to show you this. So you create that from that, and then take that, and it's part of the render copy thing, and it's putting it back in this window. So then this swaps the two buffers so that then is displayed to the user. Then delay so you can see it for a second and a half. Clear it, run the font test, which is Yeah, I've got this down to a pretty simple system, I think. The I've got it just reporting a whole bunch of it's drawing rectangles of this color, um, and then doing text over top of those. And so basically, you feed it a string where you want that top left corner to be in terms of x and y, and then you give an an RGB value for colors. So you pull get your color, create a surface that has the right. You're telling it you want to use that font that we initialized before. Then you create a C string out of the that string, and color. Obviously, that's the color that that we just constructed. So same structure as before when we were doing this BMP, creating a texture from a surface, right? So it's create texture from surface with the 2D renderer, and the surface we're pulling from is this one that we just created with that command. We then determine the width and height so that we know how much, or what it looks like when we're what it looks like when we're pasting it, I guess, copying it over. So starts with the top left corner at XY and goes for some amount of width and some amount of height. Render copy then does this. Then we free the surface and destroy the texture, just as kind of clean up here. Then so go back to our constructor. After that, entering the main loop. This is going to change. I don't like this very much. But the way it works right now is that it returns an integer, and that's a 0 value if you want to quit. Yeah, so this is like not great. It's like not great. I want to do this better, and it's probably going to get consolidated into that constructor, and I'm going to split out the functionality for so like in here is, instead of this, is going to be like, okay, what is it, like read input, then render the informational window, then render the OpenGL window. So there's going to be it's going to be broken out into functions like that. So you read the input. The way I'm talking about doing clicks is you can check the window ID against the events window ID. So basically, when I click over here, I'm gonna get a click event, but then I can check the window ID to tell whether it was the OpenGL window or the informational window that I clicked on. So that's actually really cool, because if I then know that it's the OpenGL window, I can just ignore it. And if I know it's the informational window, I can treat these like buttons, and I can test the click location against that rectangle. And I'm not sure exactly how I'm going to handle that yet, but it shouldn't be too difficult to put together, some sort of system to do that without too much complication. But like I say, the splash screen is not working super well right now because, I used to have this window just extend like 700 pixels wide, and some number of pixels tall. But yeah, you're seeing the stuff underneath it now. Anyway, so that's it's really just setting up the SDL basics, and getting that working. Working from some older code that I had. This one is actually from somebody else. This was very helpful on my chess project. Then I have this one that is the chess project that I expanded on greatly, and it's doing. Well, okay, this can get collapsed down. It's just that's how it's a class to compile shaders. But yeah, you see very similar structure in the setup. And it creates some shaders, and we're telling it that we want to use that shader program, enabling our different stuff and all this. This is just going to be, a lot of this is going to be just copied over. This does a lot more than just the, that's the whole chess program, so it's getting into the weeds there. But in essence, we're making some good progress. I want to get the button stuff working so that I can trigger like a, whatever behavior from a click. That's going to be like, when you click a button that has a certain label, then you're going to launch a certain function. And what I want that to look like eventually is, basically, you are going to navigate through some sort of button-based menu, and that's going to give you access to all the masking functions, all the drawing functions, different stuff. It's going to be, I think it's going to be a pretty functional system. The main goal here, because this is Veraldo 1.0, is to bring together all the best ideas from this project. There's been like 9 iterations of it, some of which have gotten pretty interesting, I think. The most recent of which is was really big, actually. Getting into using compute shaders. It wasn't a compute shader, but it was doing what a compute shader does using a vertex shader. It's kind of complicated to explain, but it's I want to figure out how to use compute shaders, and that's going to be how I draw into the block of voxels now. I'm going to open it up too by including the ability to use signed distance fields. That's part I'm pretty excited about. In addition to the primitives I was doing before, where for each voxel it's checked against some representation of a geometric shape. Well, then for every voxel you're going to look at the distance to that signed distance field, and then you pull in. No. So where it was a triple nested for loop before on the CPU side. Now you're launching all those as a parallel operation, and that's what I'm excited about, because that's gonna be a big shit. That's gonna be making the draw calls way faster. Probably like real time animation kind of fast, which I think is cool. And like I was doing in voxelization in a vertex shader. One of my older projects. Where is it? Yeah. Anyway, this was. The idea was basically that you have some number. Well, let's look at the shaders. I think that's going to be the easiest way to do it. No, it's vertex shaders. Yeah, because the fragment's just a pass through. Okay, so this got complicated, but it's basically like creating. It's got a set of 5 different types of primitives you could be wanting to draw some of, or 6, whatever, if you include the height map. But basically, these are defines because GLSL doesn't allow for like dynamic resizing and stuff like that. So basically, you for a given program, you got to kind of like statically define those, or like pass in like set some maximum value here, and then like pass in some uniforms to tell it like how many of that maximum are you gonna draw. But basically, for each one of those primitives, there's an array, right, based on the number of spheres. There's an array of centers, there's an array of radii, and an array of colors. Similarly, for cylinders, there's an array of points for the the top center of the cylinder and the bottom center of the cylinder, the radius of the cylinder and the color. The offsets. Oh, that physically translates it. That's kind of a hack because I was doing that engine animation that got kind of complicated, but different stuff. So triangles was 3 points and a thickness. The quadrilateral hexahedron, which easier to just call a cuboid, takes 8 parameters for the 8 different points on the corners, and then a color. So that's how that was structured, and that's how I want to do the compute shaders for. It's not exactly how I want to do the compute shaders. I'm gonna figure out a better way to do it, but this concept where it's a shader that has the parameters passed in as uniforms, and it's gonna draw what you want. Yeah, they I think it's really cool because then I'll have a whole bunch of compute shaders registered, and yeah, I don't know. I just think that's a really cool idea because like you launch those compute shaders and then the GPU draws your stuff for you, and then I would run my display code to then show what has been changed. Right, I'd show the current state of the block after it's been manipulated or whatever. So I'm thinking right now, RGBA for the color in the block, and something I want to do. 2 things really. The shit. Oh damn it! What the hell was I thinking about? So thinking right now. Oh yeah, right. So then there would be a supplemental texture, an image, right? Image 3D. It's that's the way that you're able to read and write on the GPU. It's using an image object rather than a sampler object. It's an image object. It's a different type, but it allows for writing as well as reading. And so basically, I'm just going to park that in texture unit 1 and 2. Right, the second texture is going to include masking information and lighting information. The lighting information is really cool as an idea because I want to be able to do that in real time. I want to do real-time lighting in the spirit of my older code, which was it's one of the earlier iterations of this project. I hope I can find it relatively quickly. The may have been version 7. No, I guess it was 6. Yeah, this has gotten really complicated, and I've got too many repositories to really sort through right now. Version 6, okay. Yeah, so, right, I have alpha working in this one, some like weird little ambient occlusion type stuff. I swear I had a screenshot here. Yeah, so lighting, right? So with sun shafts, being able to trace this lighting in from one direction, it's actually done in the exact same way as the display function. It's just a big raycasting thing to that goes through, and it maintains a value for each. You could think of it as pixel on the screen. It's not a screen, but it's like a shadow map kind of idea. But basically, I pass that plane through the voxel space and dim the lighting for each of the quote unquote pixels for based on the alpha value of the voxel that ray hit most recently. So as you hit more opaque objects, it dims rapidly. And as you go through more transparent objects, it dims, less in a less extreme way. I'm hoping that I can pull this up really quick. Yeah. The lighting. Okay, I do want to get more into this at some point. The way that I had done the client server operation. Honestly, that doesn't make that much sense anymore because I did like the menu driven system, and that's gonna we're gonna probably take some ideas from that for this 2-part thing. See, because there's kind of this like stack notion, and I think I want to do something like that to suggest that you're going deeper into the menu. This had a cool structure to it, I think, because you get your client executable and your server executable. You run the server over here and the client over here, and then you're interacting with this menu-driven thing to draw, right? And this is what I'm talking about when I say that you set the parameters for the thing. I'm going to be using SDL and clicking to do this, but and it's going to be more consistent than this. This version 8 of this program that I had from before was sometimes you had to send the message like a number of times, and that was inconsistent and weird. But basically, the way it works is you send it spheres, in this case, to then manipulate that block. So I want to have something similar, a little more accessible. I think one of the main things for this project right now is to make it more accessible and have it just make some sense to people who would look at it as something that's not just what the hell are you doing kind of stuff, and that's really the main thrust of that. Yeah, this one I think. Um, is that right? Yeah, because if you look at the shadows and stuff here, there's actually sun shafts. I don't know if it's gonna come through on the video there, but you can you can sort of see like the skeleton of this thing because the alpha value for these cylindrical bits are they're quite opaque, and so this is the kind of thing I'm talking about doing in real time. This took almost a day to render because I had to redraw the entire block. I had to, and that was just to achieve this rotation of the icosahedron. I had to redraw the entire block. I had to recompute the lighting to get the new shadows, and then render it. This was all done on the CPU, and that's not efficient at all. It was incredibly slow, and it was like a couple minutes per frame altogether, which, yeah, 3 minutes per frame. So where I'm looking at trying to get that is a real time sort of operation, to where with a compute shader you would pass that sort of screen through through the block shape, and that would effectively that would be how you compute your lighting. Yeah, I think that that really covers a lot of what I wanted to talk about. I've been messing with this program, Title Cycles. I can't stream it yet. I'm working on that. It's this issue where it interacts very closely with the audio system on the computer. So I have 3 separate programs to launch. I have this program, QJack Control. I have Super Collider, and then I have an Atom plugin that actually sends the stuff to Super Collider. And Super Collider is actually running a synthesizer called Super Dirt. And Super Dirt is able to play samples in a really flexible way. And you can script all that, how it does everything. I've really been it's fun because it's like playing an instrument with a text editor, and it's easy to make patterns that have enough variation to like stay interesting and like not be repeating, because I find that's something that kind of drives me a little crazy when things repeat a lot. But you can create patterns that change over time and like won't ever line up. Basically, you can introduce some random component to where it's picking random samples or different stuff like that. But I'm thinking something like that would be good as like a background thing for like stream stuff, just because I enjoy listening to it while I'm programming and stuff, and that's it may be something where I just pre-record it and then play it over that chunk of video or whatever. The oops, screwed that up. All right. So yeah, it's coming along. I think we're gonna drop the splash screen stuff for right now because it's like it's just not ideal. It's like, well, that's because if that screen is 16 by 9, which generally you're in that ballpark, and you're looking at 1/3 of it vertically, we'll call that 6, and no, 2/3 of it vertically and 1/3 of it horizontally. We'll just, for argument's sake, call that 5. It's actually slightly taller than it is wide. And that's a roughly square section. It's not square, but it's approaching a square, and it may be something to where I can, well, it's quite a bit taller than it is wide. This one's almost square, it seems like. Almost. But not really. I want to have like some sort of logo or something that appears in here while it's starting, and then it would just kind of, and then it would go to the top level menu. I'm glad I hadn't actually thought about that server-based program for a little while, but I really do like that that sort of stack-looking menu interaction where like where you show like what menu options you've selected to get where you are in the tree. So I want to probably try and do something with rectangles to kind of like step them forward, and just have it down a little bit, and put the title for the old one up here, and then just kind of like kicked forward just a little bit, draw over it with the new window, and then if you go more than a couple layers deep, then just kind of keep stacking them up. Because there's never really any reason that I'm going more than 3 or maximum of 4 layers deep. And that's I'll have to figure out text entry, because that's going to be a little bit of a thing. Yeah, this is going to be a good project. I think this is really taking the concepts from this and bringing it forward. I think doing it in SDL is going to be a big deal. I think it's really cool to be able to have the terminal to report information that's like, C error type stuff, and like the OpenGL error, like debug logging stuff. I like being able to have that as still a piece of the window. A piece of the display anyway. So we'll have buttons up here, display here, and some info here. I don't know if there's any real reason to do something like a well, no, that wouldn't work, would it? Trying to think some way that you could enter text in the command line, but that's not really super practical. Anyway, yeah. So next thing is going to be getting the menu together. Kind of what that's going to look like. Maybe pick some colors and stuff like that. And also getting a splash screen that doesn't suck like that other one does. Probably just some sort of symbol. And then make this just rendered with the text engine rather than having it pull an image for that. So that's pretty much everything. I'll be, making progress, potentially slowly, but we'll get there.